Hey guys, today we are going to have a look at edit distance problem. Basically, if we are given two strings, then we have to find the minimum number of edits that are required to convert string 1 to string 2. And we are given that allowed operations are insert, remove or replace. So for example, if we are given these two strings, then the edit distance is equals 3, and following are the actions that we can take in order to get the result. Okay, now let's see how we are going to solve this particular problem. Okay, here what we are going to do is we are going to compare characters. Okay, in our solution we are going to start from the end of the string. So we compare the two characters at the end, and if they don't match, we perform three operations on the string 1, and after performing the operations we are going to get three new strings which we are going to proceed on further. Okay, so in our example, last characters don't match, right? X and F are not same. So what we do is we insert. Okay, what that means is we are going to take the character from the second string and insert it in the first string. And what delete means is that we are going to delete a character. Okay, so we removed X, and by replace we mean that we are going to actually replace the character itself. Now after applying, we have got three new strings. Okay, so we are going to do pretty much the same thing until the boundary condition is hit. Okay, so for example, if we insert, okay, if we just keep on inserting, then we are going to insert F and then C and then D and then A and then B. So what happens is that we are going to have entire second string in the first string, and if we were considering indices, then all the indices will be exhausted. Okay, so that would be our boundary condition for insertions, right? For delete, our first string will get exhausted, and for replace, one of these strings will get exhausted. Okay, in this particular situation both are going to be 0, right? Now what happens is when we apply these three operations, what we are hoping for that at least one of these will give us the best result. In this particular situation, as you can say, that replace is giving us the best result that we are looking for, right? So that is the fundamental idea behind solving this problem. And apart from that, we are not really going to perform the actions that we have spoke of, rather we are just going to mimic it. Okay, and how we are going to do that? By shrinking the sizes of the strings. Okay, for example, we say insert, right? What we want to do is when we inserted F, we want to compare X with C, right? And we can achieve that by just shrinking the size of second string. And for deletion, we want to compare C with F. Okay, so that can be achieved by shrinking first string, and for replace we have to shrink basically both the strings. Okay, so that is the way we are going to deal with this problem. Now let's see how we are going to implement it. Okay, so one thing to note that I have already set up my main function so that we should be able to test it. Name of our function is ed, and of course it is going to return the edit distance, right? Here we want char arrays and their lengths. Okay, now if we found a match, okay, what that means is so if they match, what we have to do is we just have to shrink both of them. Okay, and if, and otherwise if they didn't match, we have to subdivide the problem, right? And also we have to add one operation, right? Now what you want is when we subdivide the problem, we want the minimum value of whichever call, right? Whichever call gives us the best value, that is what we are going to take. Okay, so minimum of three calls. Here all that we need to do is we need to mimic the mimic different operations, right? So what we are going to do is this one represents insert and this one is delete and this one is replace. So this is pretty much about it. Actually, this is all we need to do. All right, and for the boundary conditions, if m equals 0, then we return n, and if n equals 0, then we are going to return m. That is, we have basically covered all the characters in one string, and there are still some characters left in the other string. So we have to either insert those characters or delete those characters, and that is why we are returning the remaining length. Okay, so this is pretty much our implementation. Let's see if it works fine. Yeah, so our implementation is working fine. Now that we have our recursive function working fine, we want to implement a recursive dynamic programming version of this. Okay, so we are going to use same function as our reference. Okay, we are going to use a two-dimensional array. As you can see that we are referring two different indices at the same time. So that is what we are going to do. Now we have to save the values, right? So in order to save those values, once we have the value from value returned from a call, we are just going to preserve it in m and n indices, right? And once that is done, all we want to do is return this value. And once we have saved it, right, we have to use it as well, right? So this is how we are going to use it. We are going to initialize all the indices of auxiliary array with -1, so that we can actually tell that this particular value has not been found as yet, right? If we found it already, then we are going to return the same. So this is as simple as that, right? Now let's test it. Okay, I need to make a couple of changes over here. Okay, so our array is there, and then we are going to pass auxiliary array. Do note that we are the size of array in both the dimensions is +1. Okay, and the reason for that is because we are actually referring to m and n, right? So that is about it. Okay, let's see if this is working fine. And one more thing, for all the recursive calls we need to pass auxiliary array, otherwise we are not doing it correctly. Cool. All right. Yeah, so there you go. Our recursive dynamic programming solution is working fine. Now let's implement the iterative version of it, version of this particular function. We are going to use our previously implemented function as a reference. Let's rename our function to iter. We don't need any returns now. Okay, rather we need two for loops. Okay, int I okay, if they matched, what we are going to do is we are going to take previously calculated values. Same thing goes for else condition. Now, in order to mimic our insertion, cool, so we are going to have this as I, and here this, and for replace it is +1. Okay, so that is the idea. Okay, it's not very complicated, it's fairly simple, that we have just copied whatever we have done over here in here, right? And after the loops have ended, our result should be at indices 0. Okay, so this is pretty much it. Let's see if our implementation is right. Okay, now we don't want to have -1, we want to have 0 over there. Okay, so let's see. Okay, something is wrong. Okay, this is wrong. Okay, now this should be fine. There you go. So yeah, that is it for this particular video. If you want the code for this particular algorithm implementation, you can actually find that in the description section. I have given a GitHub link over there. Okay, And yeah, thanks for watching.